So I hope I did a good summary about it. Do we have any questions so far? Let me just, everything's okay? Okay, awesome. So let's dive into today's lesson. Oh, no, we're not going to Libra. Solidity, okay. All right, so we're gonna tackle 5 and 6 today, okay? Sorry about that. So I need to start with the number 1. Okay, maybe I go, yeah, that's okay. So here we're gonna, in the first part, lesson 5, we're gonna focus on ERC 721 and then crypto collectible, okay? So that's our mission here. So let me just, before I dive in those kinds of coding challenges, let me give you kinds of quick overview, okay? Since you're interested in Ethereum, you probably already heard about tokens, right? Like, I did a little bit of research about tokens. I feel like there's lots of definitions about tokens. So even this paragraph here talk about tokens, okay? So I did my own research and I wanted to share with you guys, and I hope that you are enjoying it. So it's very important to understand the token from real world, basically from history perspective to see what is token, okay? So if you're interested, highly recommend to go to this Wikipedia, which is you can see the token definitions in the different, domains, right? I even asked my kids, I said that, hey guys, in the game, like in the modern games, did you guys talk about tokens? They said that they didn't call tokens, they call something else, okay? So that was very interesting. And then this is what I'm familiar with, right? In our computer science or computing, we talk about tokens. You're gonna, if you're a programmer, you know that. But typically tokens is described as rights, like unique rights to perform some operation. And it's always used in the security aspect. So you can see session token, right? That means when you establish a unique sessions, you've been given a token, and token is a proof, for that secure session. So you can see access token, auth tokens. So those are all described in the computer science domain, okay? And then here's a economic domain, right? Which is financial. People talk about in the real life now. And then, for example, voucher, right? For example, token coin, which is, and also, casino, right? So I highly recommend it. You go through this history, because I don't believe that we're so novel to come up with the new names about token. But here is crypto tokens, right? So understand a little bit about histories, understand that, the builders who built the cryptocurrency, and then where did they come from, right? So how does those meaning being mixed together and then come up with a new meaning? I feel fascinated by after doing this research. Basically, token can be represented as a token is an object. It can be tangible, it can be intangible. And then it could be in the setting of technology, it could be setting in economics, okay? So if you happen to talk to a developer and then they happen to talk with you a token, you probably need to understand that what they mean. They did not talk about token in the economic sense, okay? So in the technology is all about authentication, authorization, for special rights, right? To give you to the access to software or hardware. In economic, it's object. It's a different object, but it's a different object that kind of like a receipt or like a special. Like you go to a casino, they give you this chip, right? Like this additional object that has a potential meaning for the value. Okay, so I don't believe token in a strict definition that is equal to the money. So that's what we need to grasp it. Token doesn't equal to the money. but token is different. Money is money, okay? So let's talk about blockchain world. So blockchain world, we're like full of tokens, right? Full of tokens and coins, so and more money. So how does the blockchain world we can truly understand the right meaning about it, and how does this at the technical meaning being translated into different use case meaning? That's what we need to follow the audit trail, okay? So that we don't get confused, right? Because then we can examine the holes and understand that, the benefits and opportunities. So ERC token. So here's what I'm gonna give you. You can think about ERC20 token or anything token in the blockchain world called programmable money, right? Ideally, to say it should be programmable token, because remember, token not equal to money. So it's a program plus token, right? It's token plus program. And then how does the program look like? Program is smart contract. Done. That's it. It's economic. It's trying to represent some economic concept of in the real world called token. Plus, you use the program to manage on that, right? So that I believe that's the right definitions about it. Of course, anybody can give their own definitions. So let's talk about program. So what are the program? Program, very simple. You have data model, you have functions, right? So that's what you say program. So what are the key functions, for ERC20 token they provide? Forget about nodes, right? You just like imagine, like close your eyes, imagine you're going to specify what this token can do based on the histories you read it, right? For any token, I make sure the token can transfer. So that's the function, right? So that's why they come up with the syntax called transfer from, which is you give from address to address and then some token reference ID, which is called token ID, okay? Because token is also can be represent, the whole things, right? As a contract. Okay, so that is a specification of this function. And then for this program, right? Imagine that you probably need to know how much. So that's a balance of, right? So for given an address, you want to know how much this address, which is this owner, owns that. So that means this token, besides it facilitates the function, it has data. It has some ledger, right? Of course, you're gonna have some ledger to track the transactions and also report it. Who has how much? How much token? So that's a balance of. It's kind of like a get, right? Get balance of by providing the parameters. And then this is data structure called balances. You can see it's just two columns, right? Like mapping structure. You have an address, you have this. So for example, you have a Hui's address, how much, Mary's address, how much, Howard's address, how much, right? So that is ERC20 token. They call this called standard. Okay? So when someone give you the standard, then in the computer science domain, that means that you can have an actual implementation, which is you can say, maybe you come up with like Doge token, right? Like Doge token is ERC20 token, and then you can implement those functions. That is how all sorts of tokens on the Ethereum platform, if they said that they are ERC20 compatible, what does that mean? It really means that they inherit this parent contracts, and they have to implement those functions in their current implementation. Okay, so we understand the token, we understand the ERC20 token. Now we need to understand 721 token, right? And you say that, wait, what the heck about those number? Where does that come from? I mean, you ask great question, right? I love curious people because they always ask why. So same like me, like I want to find out why they call that, right? So ERC is kind of like Ethereum request. I forgot the C, but it's basically in an open source project. if you are open source developer, contributor, they are typically go to the GitHub, right? The GitHub is the place like all of the coders can exchange ideas. So they're using like 20 maybe at a time. It's just like the 20th, proposal. So 721 is the 721 proposal, right? For the Ethereum Foundation, people like propose the ideas. So that's how the number come from. And then, so ERC 721 token is someone proposed to Ethereum Foundations about we need to have a different style of the token or different, types of token. So again, it's token plus program. So what is token for, and what are the program functionality or structures? They wanted to specify that, right? So the main purpose is ERC20 token. They mimic some kinds of called fungible aspect of the token. Means that the owning one token versus owning 5 token, it's the same. Except the numbers, everything's the same, right? And then 5 tokens can be, I can give you 5 1 tokens. So it doesn't matter. Each unit doesn't look exactly the same. That's the ERC20 token. But ERC 721 token, it says that no. We can model something called unique stuff, right? So that means the unit of each token totally represent a unique asset. So could be fine art. It could be something that is unique, right? But it has a value. So it's a tokenized versions of the actual stuff, right? When I say actual, people may challenge that, wait, what about digital art, right? So again, back to the foundational meaning of token. That's what I refer to. So again, token it could be objects, tangible, not intangible. Token in the economic sense, it represents something, it refers something, must have a value. But that token, it could be the same as object. It could not be the same as object because it could be like a voucher, like a banknote, a receipt, or gift card, right? Because you can trade it to get the actual stuff. Okay. So from function perspective, you need auctions. So it facilitate auction, it facilitate escrow process. I don't know whether you guys have understand the auction, but it's basically like bidding, right? If you are eBay users, or if you are like having to purchase some expensive, like use the car or or art, there's some auctions going on, right? Escrow process means that there's a third party because of swap, right? Swap the token with the actual stuff. There's a risk involved to that. So escrow process is kind of like in the middle. You have to approve it. So there's a like in the middle process, approve it, hold over there, and then using that as a extra stop, and then can the value be swapped? Okay. So it's not atomic, right? It's not like say that. So there's a like atomic swap, but escrow is intentionally introduce a third another step to kind of call approve it. Okay, so I give you this background. I hope you enjoyed it. Any questions so far? Okay. All right, let's go to the coding now. I will continue on that. Okay, so you can read this, but basically that's what I mentioned about there. And then why does that matter, right? So what's token standard? What's the ERC token? How the ERC token was born, and what's for that purpose? So the exercise asks us to implement a token, and then so we have to specify the contract, okay? And then, oh yeah, before we started, remember that everything starts with say, hey, I'm an Ethereum contract. So you have to kind of do this, right? Just make it bigger so you can see it. Okay, So, you know what? Let me make my screen smaller. You don't need to see me. Okay. All right. So we put this programmer, and then we need to import. Okay. So we need to import another contract we already written last time called zombie attack. And then we said that we need to yes, that's our contract name. We're going to say that that is inherit from zombie attacked. Perfect. Simple, right? Declare the contract. Okay. I mean, sometimes this course has this, you know, not very intelligent enough, but that's okay, right? Just remove that and move on. Okay. So we give the contract our skeleton. Now we need to fill in a contract, right? So here we need to not just inherits from this. We have to say that inherits from the ERC 721. So remember, I already talked about ERC 721, but I have not talked about, you know, what the functions inside of that, right? So we're going to talk about it. But let's just go ahead and do the exercise, and I'll come back to explain it. So first, we need to import this. Import. Okay, don't forget the semicolon. All right, and then we said that add an extra. So you're going to do is this. Okay, that worked, right? Awesome. Okay, so let me go back to my notes to talk a little bit about ERC 721 standard. So we talk about ERC 20 standard. We have not talked about ERC 721. But the key functions, we're going to look at it, again, is for the purpose or to facilitate auctions and an escrow, right? So of course, you're going to have some balanceOf. Remember balanceOf? balanceOf is talk about giving the owner, you know, what's the value. And then for ERC 721, because it doesn't have this, it will have this mapping. Okay, we double check it, but it will have owner of, right? So you can say who owns this ERC 21. And then you will have a transfer from, which is facilitate this ERC 21 from one owner to another owner. And then because of the escrow process, you have to have a proof. Okay. One thing that's very important, because we're gonna quickly go into some security related questions. That is, who can approve, who can transfer, right? Those are kind of a view or get methods. But for the functions that is performing the task or operation that change the states of the tokens, we always ask ourselves, are you the right one to call this? You know, who can approve, who can transfer? So you can see that here's the different roles involved in the ERC 21 when we think about the logic. Okay, because you will have old owner, you will have new owner, you will have approval, you will have message.sender, which is caller. Okay, so imagine message.caller. Message.caller could be owner, right? It could be like the current owner. Maybe I should say that it's called current owner. For the current owner, you know, he's the one called that. Okay, it could be prover call that, right? It could be hacker call that. So that's the security things you need to think about it. It doesn't always mean the right person to call your function. It could be unauthorized person to call your function. So that is typically security control. You have to examine is you have a positive aspect, you always have a negative aspect. And often people neglect negative aspect. They don't code it to anticipate hackers. That's the bar for us, is to imagine there's a hackers. Imagine there's there's a abuse of calling your functions, can your function handle that, right? And we we seldom talk about that in the typical programming language. Okay, but anyway, that's what we learn here. Is make the contract strong. Okay, defensible. Okay, let's look at the balanceOf because that's what we want to learn first. So balanceOf, look at the function. It takes the owner and it returns a balance. Simple, right? And it's external, means external contract can call, and it's view. Okay, and then here's the owner by giving this token, unique token, and then it will return who is the address. Own that token. Okay, awesome. So we're gonna just implement this. So they want us to return, right? Okay. Keep in mind, we're implement zombie as ERC 721. So we already have a data model that is described in the ERC in this contract. So we don't have to describe data model over here, and we just simply use it, right? So we said that return. We need to return balance of this owner. Okay, so what we want to return? Okay, we just want to return how many numbers of the zombie this owner owns. So we need to find out data structure that holds that, right? So if you go here, how many numbers zombies owns, right? Okay, so we need to find the right data structure that helps us to return this. I think it's probably either in another structure, yeah, zombie helper. So all the way back to the feeding, right? Because we have data model over here. All the way back here. Yes, that's the places we have all the data structure. Look at over here. If you're given an address, you will return how many numbers the zombie owns. So that is the right data model. We're going to use it. Okay, so we just simply say by giving the address. Okay, and then it should data type compatible. Okay. Okay, next one we need to implement the given the token, which is ID of the token, and then we wanna return the owner. Okay. Awesome. So we need to find the data structure. Same thing. So which data structure that return the owner? This one, right? By giving the identifier of the zombie. And then you return the address. Okay? So that's how you get the two implemented, because we're saying that we're implement this, and then we're gonna do this. Okay. Awesome. So here they want us to do some code changes, which is called refactoring. So let's see what the code changes they want us to do. Okay. This is the reason. The reason is go back to the new contract we introduced. So we introduced new contract because we wanted to implement ERC 721 with additional functions. Okay. Unfortunately, we happen to call the same. There's a function called owner_of. Okay. But this owner_of happen to be the same name in here. If you guys remember that, we introduced a modifier called owner_of, right? So that's causing conflict, because you can call this right here because you haven't implemented the ownership of function, you know, but now we have conflict here. So we have to change the name because we cannot change the name in the ERC 721. So we have to change the name. We call this modifier here. Okay. So that is the reason why we need to do the refactoring. So you just change the name, give a different name, right? So that's what they want us to do. No big deal. I just change my modifier name to a different name. So if you change that, that means every places you're using this, you need to change, right? So let's see what else they want us to change. They want us to scroll down to this function called feed and apply multiply. Okay, and then here, because we're using modifiers here, right? So we need to change to the different name. Okay, so that's how you address this naming conflict. Okay, go over here. So, okay, so we go back to this, our ownership 721 contract, because now we're going to move on to address transfer from, okay, and improve those functions. Okay, so let's see how they want us to do. All right. So they want us to introduce a new function called transfer from. And then this is a little bit naming convention. Okay, whenever you see underscore function with underscore as a prefix, it's kind of to imply that it's private function, right? So it would take 3 parameters and it's private. See here? Yeah. So we're gonna do the same. And you may wonder that why, right? Can you directly implement inside of that? I think the answer is yes, but it's also probably for security reason. You know, they wanted to isolate certain things in a private function. It kind of put in some logic in the private, leave some kinds of a checking in this public functions. Okay. Okay, so now you can see we're introduced this private function first, and then our goal, right? Our goal here is there's a because you're transfer. That means you probably transfer from current owner to the future owner. That's what you transfer. Okay. So, and then we have to kind of how does that work, right? So it's all about data. You know, we just need to ensure our data record things properly. So we have to ask ourselves which data we need to touch to change it. So that's why they want us to think about that. Okay, so we need to think about 2 data structures because that's 2 important data structures we need to change so that they can reflect that the ownership has been changed. Okay, so one is owner_zombie.count, another is zombie_to_owner. Because for the current owner, right? Imagine that you're a transfer. That means your current owner, you're gonna decrease the zombies you own. Before you may have 3, now you have 2. Make sense? And then for zombie to owner, which is another data structure called mapping, right? It tells my zombie ID and then my owner. So that means maybe let's see, the first zombie, the current owner is Hui, but after I call in this transfer, this data structure need to be updated with the zombie ID now being married, right? So that's what they said, that whenever we say transfer, you need to think about it is, well, what are the critical data that can reflect that the ownership actually transferred. So it's actually touched data. Okay, so that's what we need to do, right? So we just say, all right, we need to touch the first structure. That means for the current owner, the first one, I want you to for the receiving owner. Okay, let's see. They want us to do receiving owner first. That's fine. So that means you increase it, right? You got 1 more zombie. Okay, and for the current owner, you lose 1. So that's data bookkeeping going on here. Okay, same thing here, right? We said that for this data structure, for the zombie ID identifier, now you have a new owner, which is this guy, because before is a from, right? That's how we implement this, okay? They said that there's a last step we need to do. It's called event. Yes. So function is to-do list, right? You just prescribe the procedures. Event is kind of a raise the notification message. We have an event called transfer in the ERC 721. If you go here, it's called event, right? So you need to notify, it kind of like raise the message and say, hey, I'm done. I finished this transfer. So that's what it does. If you remember that raise event called emit, so you just need to follow the event syntax, right? Like parameter, make sure it matches. From to token ID. That's it. Uh-oh. Maybe too complex. Let's see what happened. Oh, yeah. Do I need to call that? Just make sure. Oh, yeah, I put it in the wrong spot. Okay, I shouldn't put it in here. Remember, I should put it in here. Yep, see? I did not specify right private. Okay, then we get it. Any questions so far? Admin, Varsha, okay. I don't see there's an admin, because whatever we use admin or owner, owning, that's kind of the semantic, right? Depends on whether you have this modifier you define, So you just need to ask yourself, are you because owner is owner. Owner from the economic perspective is different than the admin. Admin could be the manager, right? It's not an ownership. So we often, in a smart contract, you start with ownership first. Okay, let's go to transfer continue. Okay, so that's what do they want us to do? Okay, so in this function, which is external can call, they want to add some logic, right? And also call this. That's what we need to do. So is there any first one? Yeah. So they want us to introduce a proof step. So that's why we have to have a mapping here. So we're going to have a mapping. We're going to say map with structure, right? So it's a unit. You should map the unit equal to address. So this trying to say that I say, hey, they want to make sure the owner or the approved address of this token can transfer it. So did you see that? They're introducing, besides the owner as a role, there's an approval. It could be the same person, it could be a different person. That means it could be different address, right? So that's approval process to use this data structure to facilitate. So that's how you define a structure that can help you to implement the approve logic. Okay. All right. So we go back here. They want to add a requirement. So the requirement here, the requirement is implement this. Okay. But we need to say how do we require. So we need to add the logic. Make sure only the owner and or the approval of the address can transfer it. So there are two conditions we need to code it. So you just say that require, let's see what we want to require. We want to require the owner, okay? So remember how to get the owner? This one, right? Easy. We said that, hey, for this token owner, you either equal to message dots, your current message, the caller either equal to the owner, or here's how you specify the or is approval. So how do I get approval? Address, this stuff, right? So you just do this, same thing. You're doing lookup for this token ID, and you are saying that you better to be approval. So that's the required logic, okay? And then here we just need to call this internal one by passing the from to token ID. Okay, that's how that works. Okay, now we successfully implement the transfer. We have not implemented the approve. So now here we're gonna finish the approve, okay? Remember the approve, right? We have data model now, and then it just matters about, reflect your data structure properly, okay? So, so this is how they want us to do. The owner calls approve and then give it the proof address of the new owner, and then the token ID wants him to take it, okay? Remember the actual step, right? The actual step here is someone wants to transfer from owner to the current owner to the new owner. But in the middle, we need to do the approve. So that means there's an approve address in the middle, right? So that's where we need to update the approve address for this one, okay? So let's see. We just want to make sure only the owner of this token can do this approve method. So that's why you call this modifier, right? So modifier, what is modifier? Modifier do actual checking. Modifier said that, hey, can you look up this token ID for me and make sure the caller is the owner. So that means this functions can be only called by when the caller declare themselves as the owner. Okay, for the body, this is how you inside of the body, right? Inside the body, you do the data updates. You say, hey, for this one, make sure approval is the address that has the rights to do this approve. Okay. All right. So we're almost done about the approval, right? So let's go over here. What else they want us to do? Final step. Yes, do the emit. That's what you need to do. So let's go ahead to the emit event. So the event is approval. So you just call the right name for that event by passing the right parameters. So say, hey, that's the notification for that event. I forgot it, which is owner, approval address, and token. Owner, where's owner? Message.sender is owner, approval address, and then token ID. That's how you raise the event for this approval. Is there any? Oh, message, typo error. Yep. All right. We have successfully get the, ERC 721, all of the functions to be implemented. Any questions so far? You guys follow? Cool. Let's go back. So now we're gonna look at another security concern, okay? Or you can call computer, like errors, you have to deal with that. It doesn't have to be security, right? But it affects the contract. So it's called overflows and underflows, really with the math, operation. So if you are already a developer, you kind of understand this concept already because it happens in another programming language as well. But if you're new, the idea about overflow and underflow is really with the math, numeric data types. Okay, so those numeric data types, if you recall that we have different subtypes of those numeric ones, right? We have UNT 8, 32, depends on how large you wanted to have your integers here. But if you're using small, which as you can see here, if you specify this one, that means the range of this number is from 0 to 255. That's the range. So overflow means that if you accidentally store the value that is outside of this range, right? It's like bigger than 255, this variable will have overflow problem. If you're kind of trying to store like lower that it's the minimum value of this range, you have an underflow problem, okay? And that happens because you're doing the math operation, right? Either to add, subtract, divide, blah, 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 it has a risk to cause that overflow and underflow. So Ethereum doesn't handle that nicely. So that's why there's another lab called OpenZeppelin. OpenZeppelin actually wrote a set of the smart contracts, and of course open source. So they open source their library for us, right? So they create a library called SafeMath. So that means this piece of code is already available for public use, and then we just use it to address this problem, okay? So the following couple lessons, we're gonna the sections over here we're gonna learn is how to use the SafeMath for all of the math we're using here, so that we kind of we don't want to have that risk, right? So that means for anything that is using plus or subtract, add, whatever, we need to replace it with the SafeMath. Okay, so let's see how the SafeMath gonna work. So in order to use the SafeMath, first you have to import, right? Of course you're gonna import, and after import you're gonna say, hey, I want to use SafeMath. This is how you have to declare that. So let's just go ahead and do that. So we're gonna say import, and we have to say that where's that library, so I can call SafeMath.sol, and then we're just using the syntax like this to say that, hey, for all of the variables, that is I use this, I'm going to use SafeMath, okay? So SafeMath is going to introduce some functions way. So instead of this kind of a very native expression way, right, to kind of expressive way to specify the math, they're using like function. I honestly say it's not a very intuitive, but unfortunately that's kind of how the current Solidity provides that. I mean, in other programming language, they have a different ways of address the same problem. But for right now, we have to kind of follow that. But look at that. Instead of you using this very common, elementary, everybody knows how to express the math, now you have to replace it with this function, right? So it's not intuitive, but we have to address this overflow, underflow. That's the trade-off. Okay, so we do this. All right, so we're gonna actually change our codes to get rid of all of the plus, minus to implement that. That's what they want us to do. So the idea here is to call those functions to simulate add, plus, right? To simulate those. So basically all of those we're gonna, right here, you can look at here, all of those syntax we're gonna use, we're gonna replace with the function. So if you have plus plus, you're gonna use this function like this, okay? So this is what we need to do. We said that for this variable, we wanted you to incremental by 1, means add a 1. So we're gonna say dot add 1. That's how you implement SafeMath. Again, for anything you learn, right? Like somebody said that follow this formula. For all the developers, if you're serious about programming, you always want to chase why. Why? What's the problem they try to solve? Okay? Because maybe there's a better way, right? So this is SAP, right? Is this better way? I don't know, but it works. So that's how we learn here. We have to use SafeMath. Maybe there's a better way. Someone will say, hey, you don't have to use SafeMath, but still achieve the same goal. Awesome. So we get through the SafeMath. Gosh, we have more need to update it, right? Because for every area you're using plus plus and minus minus, you need to replace it. So this is not fun, but we have to go through this. So besides SafeMath, you can do 256. You can do other integer as well, but you have to use different using method, right? So that's how you do. And don't ask me why about the syntax. I have not done the research, but let's just follow that, how they do this. Okay, so you do this, and then we find out what are other places they want us to change. They want us to change this, right? I'll add. Okay. Is there any other places they want us to change? No? Cool. All right. Man, is there any 2 more places? Oh, here's another one. That's what they say. For all the places you have to change this, right? Like wing count. Dot add. Levels. Level, yeah, not levels. Dot add. Loss count. Is that add? I think it's add, right? Okay, here's another tool. I just copy that. Oh yeah, I cannot copy that because it's, make sure your left and right matches, okay? Last one. Okay, that's how you address all of the SafeMath. Simple, right? It's not hard to kind of refactoring those code. Okay. So in this chapter here, you can see it's just introduce something is how to do comment, okay? So programming language is a language. So you can see this editor helps you to see different colors, help you to know keywords versus non-keywords. There's a special line called comment line, right? So here's a different way to do comment. You can use 2// to represent the single line as a comment. You can also use slash star, that's for a paragraph to be a comment, but make sure you have this closing, you know. And then there's a special one. The special one called like kind of like a code function specification, right? Comment. So that using the 3/, okay? So for the 3/, what you do, I mean, it is the comment, but it's kind of like you help other developers to understand your contract a little bit better. This is very important because in the programming, in the developer community, we all appreciate another developer write the codes that is readable, because I can pick up your code and continue enhance it. But if you have no comments like this, it just makes the next developer who reads the code very hard, right? They cannot understand that why you code this way, So it's very important you have that discipline that is not just that you finish the coding logic, but you also wrap it with some good comments so that the other developers can read that very easily. So that's what they asked us to do. So they introduced some kinds of a convention, which is you can help other developers to read better. So you give the description of the title of the contract, author, and then like which kinds of development notes, right? Like say, okay, this inherits from ERC 721 spec. So that's what they want us to do here. So I'm just go ahead and copy that because save some time. They want us implement title, owner, right? And then dev. Let's see whether that work or not. Yeah, so they don't check details as long as you have done that, the syntax like this. Okay, so basically that's comments. Woohoo, we finished this lesson. I think we did a good job this time, a little bit faster. Anyway, if you remember that, right, what we have done, we basically introduced token. We introduced 721, and how does we, if you are the contract, need to say, hey, I'm also 721 token. How does that work? Is really trying to finish the implementation details for those standards. That's what you need to do. Okay. Let me see, any questions so far? Nice, thank you. How long to let me know the feedback? Okay, we're gonna move on because time is very precious here. And then I'm so excited to finish this last lesson, okay, because it's just so exciting. Oh, no, not this one. Why they don't have the next? Oh yeah, sorry, I'm keeping back and forth. Silly. Okay. All right. Now you already have good foundations of all of the smart contracts now, I believe. Now we're going to talk a little bit about the dApp and how does front end, right, glue things together with the smart contract. Because so far we have focused on the contract, which is the Solidity parts, which is later on going to deploy into the blockchain. Okay. So the first thing we want to introduce is called Web3.js. Okay. So Web3.js is a library provided by, is JavaScript library provided by Ethereum. So if you're not familiar with the JavaScript, this is probably out of the scope for this live streaming here. But it's kind of a front end, right? It's a front end. You have HTML, you have JavaScript, you have CSS. That's how you build the front end, like any kinds of a rich web page, web application. So decentralized application, of course, it's application. So you have some front end code. It will sit into certain device, and then it will utilize this a third party library, right? So that means besides your code, you have to import, in a sense, about third party library called Web3.js. So make sure you know how to import it, which is we're going to walk through the course. So this we're going to figure out how does this call topology work, right? Because So in order to call it, this is very important. You need to know on your left side how you need to engage with the right side. So we need to have things in the mind, right? We need to know the address of the smart contract, which is you code a smart contract, you deploy it. Because otherwise, which contract you're gonna call it, right? So you have to know that address. For the front end, you have to also know which functions you're gonna call, because in your front end, you may have some user interface functions. Could be, hey, I need to call get balanceOf, or I need to call get ownerOf, right? So those are functions of view functions. You may have a function which is perform operation like transfer or approve. So those are functions. We have to know that how we actually code it in the front end side, not in this side, because we already coded the function definitions in the smart contract Solidity part, but we need to implement the caller part, right? Also, you have to address the variable, because you're going to call that. You have to say which parameters, which actual value from your front end that is actually passed on, so that you can actually call it. So that will be the front end. You have to, whenever you code a front end, you not only you have to worry about the user representation UI part, you have to represent the JavaScript, which is how you integrate it with the Ethereum smart contract, right? So conceptually, that's what you need to do, but let's look at the details. From technology detail perspective, how they actually established the channels, how does that actually work? So there's a one technology called RPC, okay? Again, did you see that? Conceptual versus actual technology, two different things, right? But you need to know the technology as well. RPC stands for remote procedural call. So remote procedural call it's kind of like a SOAP or REST. It's how you can call things across the network, right? Across the internet, across the network. So it's called remote procedural call. In your mind, you can think about them as a protocol, as a standards. So in the Ethereum, they adopt something called JSON RPC. So JSON is another technology term. So again, you need to do your own research, figure out what's JSON if you're not familiar with that, okay? But JSON represent a JSON data formats. So you can see this is a JSON format, and then this is how you specify key value pairs. And then whenever you do this, you utilize this RPC mechanism. That's how you establish the channel across the network. So that's how the codes and data actually pass on, and the things are fetched back and forth, right? To make that happen. So if you're interested about JSON RPC, there's some, just either Google it or use this link to familiar with that, okay? So the ideas here is, remember, we need to call it. How do we call it? So what does the syntax look like? So the syntax looks like is, once you have a contract, assuming this is your contract, right? Contract name. So your contract object. So contract object, and then you can say dot methods. So you basically imagine that you're gonna somehow able to see all the methods, this contract provides. And then you just simply provide a method name called create random zombie, which is the method you already specify over here, and by passing some parameters, okay? And then there will be some like send. We're gonna talk about all the details, how you can engage with the functions, either the view functions or the view function or the, let me just move this around it. I just feel like we did not see that properly. Okay, so I have done some summary here. We're gonna go back to revisit here. So don't worry about this graph, okay? We're gonna go through the lessons and see what we need to do. So I just introduced what is Web3, okay? Now we're gonna just code it. So here, remember, it's it's a additional JavaScript. We have to import it. So we're coding different language now. Okay, this is a front end. This is HTML. This different language. It's not a Solidity. Often, you have a front end developer to do that, right? Or if you are a full stack, which is you worry about front end and the back end, you can learn both languages and then try to achieve it. Okay, so this is how that works. So you use this special syntax script, and then you provide the source, and then this tells that how you do the similar like the import. You know, you're just using different syntax to achieve it. Awesome. So now you have a Web3 JavaScript to be somehow tell the HTML to load it. Now let's see that Web3 provider. Okay, cool. That's another concept now called Web3 provider. Okay, let's go back to here. So what is the Web3 provider? Just from high level, you just think about it is any provider, actual provider who kind of comply with Web3 standards, right? Web3 protocols. So on Ethereum, there is a provider called Infura. Infura probably came from the provider called, I forgot the name. Yeah, Cloudflare. Okay, Cloudflare is one of the providers. They have a different products called Infura, and then so what does Infura does? So remember, Ethereum is a peer-to-peer network, right? So that means there's a concept called node. Node is the computer who offer this computing and also the data storage. So you as a node can participate in the Ethereum, network, which is you become a node, right? You become a node. You have a full copy of Ethereum, code bases and the data structure as well. So that's why this whole peer-to-peer network, if one of the nodes left or hacked, it doesn't affect the whole network, right? So that's called node. So here's you, right? You have a computer. You have a computer resources. But the question is, did you want to become a node? Or did you want to just, hey, I want to rent a node, right? So that's why there's interesting things going on here is you don't have to become a node. That means your computer doesn't have to say that, hey, I want to become a node, means that I download the program, I download the whole Ethereum program, the blockchain, and on my local box, right? You don't need to sign up for that. But you said that I'm just wanted to be a dApp, So what does that mean? It means that under this box, right? There's a box which is your desktop. You wanted to establish a channel. You wanted to have this kind of a channel with somebody who has offered this node, right? So that's why you had there's an Infura, which is at another location, another computer who already signed up as a node. So we have to establish is our dApp with the node, because node has the blockchain, right? Node has all the details of blockchain, etc. You have to always keep in mind, this is not a client and a server architecture, which is traditional we have in the mind, okay? This is your computer and a node relationship. That's what you have in the mind. And this node is already replicated the whole blockchain, right? So our RPC, whatever the JSON RPC remote call we're going to establish is my computer with a node, that relationship. Okay. So now we understand this box relationship. We also have to understand something called browser, right? So what is browser? Like right now I'm using Google Chrome. There's a better browser called Brave. Browser is a program. Come on, right? It's another program, which is help you to type they have interface. They have a call. Browser has a browser data. So browser has a browser data store, and then so why I need to tell you this way, because we're gonna talk about those relationship. Otherwise, we're gonna confuse about which data store at where. How does the key, security aspect, right? And you have this private key. So Remember private key? Private key is super important. Private key is the key to sign the transaction, to access the asset that is kind of a managing on the blockchain, right? Again, blockchain is not one thing. Blockchain is a bunch of the nodes and the data structures, okay, and the protocols. That's a blockchain. So, and you have to be very careful. Is where we have to be very careful is where we store the private key. Okay, so today private key can be stored. Of course, private key need to be stored at the close to you, and it has to be isolated. Means that only you know about it, right? So the ideal place to store the private keys, your secret private key, is actually in the hardware, right? Like hardware wallet, which is you can unplug, which is you don't want it to always expose on the internet, always exposed on your computer unless your computer is isolated. Your computer is not isolated. You use Wi-Fi all the time. You view the browser all the time. You look at the email all the time. So it exposes the risks. What if you accidentally click the scam, right? Or go to some wrong website, or you download something that causes your whole box, which is your local computer, be compromised. So that is the whole thing about security. If certain bad things like ransoms, whatever, that has a risk because you store your private key on your local box. So that's, again, does that actually happen? It may not happen, but it's a risk. So that's why it depends on you how much assets, how many assets you have, and how important your key, right, to manage on that. This is a different topic, like key management. That's a different topic right now. But I need to give you this topology so that we can understand this code nicely, okay? So now we're introduced nodes. We're introduced Web3 provider called Infura. It could be other brand name, but what do they offer? They offer Ethereum node as a service. That's what they offer. Okay. So now we just need to, in our client dApp code, to somehow refer to that Web3 as an object, because we just import the library. We have not do that, to kind of call that, right? So this is how you set up the Web3. So you say var Web3, and you new Web3, and by giving that Infura location. If you do that, and then when you run the code, establish that kinds of you say my dApp, now I can talk to the Infura now, right? That's how that works. So let's see what we want to do. Okay, there's a MetaMask. I'm gonna talk about MetaMask, okay? Okay. All right, let's talk about MetaMask. Okay, so I don't know whether you guys have used the MetaMask before, but let me just go to my another browser quickly. Okay, so this is a little bit ugly, okay, but let me just pull a one here. Okay. So this is a MetaMask, right? So if you have not stored it, this is a MetaMask. So MetaMask is a Google, not a Google, is a browser extension, which is you can install it. So it has some interface. It has some kinds of different accounts you can create it. So it's just like a web UI, right? Like a wallet features, you can have it, and you can use it for different network. That's what you do. Okay. So let's go back to this. What is the MetaMask that play in the whole game? Okay. MetaMask is also a third-party provider. And then right now it has user interface, which is extension. It also has a backend stuff, right? So we wanted to partner with MetaMask because MetaMask also provides Web3, stuff. So it means that the MetaMask also has a node over here as well, besides this front end. Okay. So what it does here is, I don't know what do they call MetaMask at the backend, but they must have MetaMask in the backend as well. Okay. So we're gonna leverage the MetaMask for key management, because there will be certain actions we can call, which is we want to form our dApp directly from the node. Okay. But we also wanted to, there's another way to do that, is we basically said that if somehow our browser already implemented MetaMask, my JavaScript can simply leverage the MetaMask. As long as I have some kind of a channel to talk with the MetaMask, and then that's the way we're gonna reflect it, the data, all the way past to our dApp and show to the users, right? So that's kind of the relationship there is I forgot to draw the line over here, but often dApp, you have a choices for develop the dApp, which is you don't have to always rely on MetaMask, but you can simplify your coding by just focus on your smart contract coding, and then leverage the MetaMask already have a secure channel for you, and they also have a key management for you, right? So you don't have to implement a lot of things in your dApp, unless your dApp is another wallet. You can implement a dApp as a wallet, and you do everything similar like a MetaMask has already done for you. But if you don't want to implement the wallet, then you just use the wallet, which is MetaMask is the very simple versions of you can use it. So I hope I explained that clearly, but if it's not, I think reading those messages here, this description here will also help you as well. So what exactly we're going to do, right? So we want to make sure in this HTML, somehow we can use the Web3. Okay? So the way to do it is to implement this logic here. So they want us to just simply copy paste and then put into the script here. Okay? So we have done that. Okay. So the logic here is just said that, hey, when you load this browser, right? I'm loading this browser here. They want to make sure the MetaMask already installed. So for example, this browser here, I have not installed MetaMask, so you don't have it. So if it's not defined, it's going to try to say that, hey, please using this current provider, right? So that's how you actually get the Web3 object here versus direct channel, which is you can always call this, right? So there's different ways about getting the Web3, which is I mentioned about Infura also is a Web3 provider. So back to the graph here, you can do this way, which is you knew the Web3, and then you call some Web3 provider to rent that node as a service, or you just, if you already installed the MetaMask, you just simply get that variable from the browser. So that's how you get a variable from the browser, okay? Okay, so we got that. Now we have to introduce another two concepts. Man, there's a lot of new concepts today, huh? It's called ABI and then contract address. So you're already familiar with contract address, so we don't have to worry about it, okay? So contract address, it's just another Ethereum address, but in this time, Ethereum address is not just simply hold the tokens or balances. It has a code, right? So it's your smart contract code to deploy into the Ethereum. What is the contract ABI? Okay, so ABI stands for Application Binary Interface. So think about this way, right? You use the Solidity to code it, but Solidity is one type of language. Your HTML is another type of language. We needed something in the middle so that your HTML know how to talk with that, right? So it's basically is the compiler output, which is when you compile, look here, when you compile your contract and deploy into the Ethereum, Solidity compiler will give you the ABI. So think about it as output, right? So there will be the output as ABI, and this ABI is going to be used in your HTML. That's how you can call smart contract in your front end. Okay? So we need to use ABI.js. So we have to create a new name, right? So they already help us to do that. So this is the ABI output out of the compiler, which is already have it. So you just need to copy, paste, and then put into your project file so that it's close to your HTML code. And then in here, we just refer to it. So how do we refer to it? So in your header, you refer to another JS, right? Fire. This is just do the same thing as this one, and we're using different name. Okay, so if you do that successfully, you glue your HTML with this API. Okay, now we have it. So now in here, which is the script part, they want us to declare a variable. Okay, why? Is because we're going to show it on the front end, right? So here's how you declare a variable in JavaScript. So we said that show zombies for any account, right? Depends on account you have it. So okay, we declare this variable as a second step. Now we need to add a function called start apps. Okay. Function this. Okay. And we're gonna fill in the body in the next two steps. Okay, right here. So the first thing is declare a variable called this. Sure, I'm gonna declare the variable called this. And then that is equal to some string. Okay. Right now, let's don't worry about the actual contract of your address. We're just using this mockup here. Okay. Okay, so now we need to truly get the contract instance, right, in your front end code. So that's what you do. So you say that, all right, set this one. Okay, so this variable is actually the contract variable, okay? So we set that to a new contract, right? Do we have an example here? Yeah, that's an example. See, my contract equal to new, this one, by giving the parameter of the ABI and this. Got it. So we just need to say new, and then you give the address, which is this variable, and then you give the variable called your ABI, right? Where's the ABI I can call? Oh yeah, this ABI. Okay, and you may wonder that where's this variable, right? I believe this might be here, see? That's how you get the variable, because you already imported. Okay, cool. That's how we, on the dApp side, to new up the contract instance. So far, we have just kind of getting the everything kind of established, like initialization, right? We even haven't called the function yet. Okay, we have some issues. Why new address? Let's see some. Oh, see, I did the wrong parameter sequence. So ABI first, address second. Okay, nice. Okay. All right, now we're ready to call functions. How excited we are! You know, finally we can call our contract functions now. So the first thing, so in this library Web3j, right? Web3.js offer two types of the kinds of a wrapper. You can think about wrapper to call the actual functions on the smart contract. One is called call, another one is called send. Okay, call function from Web3 that allows you to only call the view and the pure function. Basically, is read-only, right? Read-only situation doesn't change the state of the blockchain, doesn't cause any, gas, and user doesn't need to be prompted to sign a transaction. That is the view and the pure. Okay. So the way to call it is just like say my contract object dot methods dot my methods by passing the parameters, and then you have to hit this dot call. Okay. So that is everything. You need to chain it using the dot way to call those read-only functions. So send allow you to call the function that changed the state, right? Which is, you can see this note here, very important, is when you change the state, it definitely calls gas. So if you call the gas, you have to kind of get out of your wallet to pay that, right? To sign that. So you have to sign a transaction. So you see, it involved the complexity about how does your dApp automatically pop up the MetaMask instead of you click the MetaMask, right? So that means we have to somehow glue them together, and then the MetaMask, and then you're gonna in your dApp to call the send method, because that's ultimately one line to trigger that. The way to do it is just the same thing, whatever the functions, and you call .send. Okay, so right now let's just focus on call, which is access data part. So how do we call the smart contracts functions that can bring the data back? So we wanted to show this zombie because zombie is a public variables. So if I somehow can show it, I probably can show it on the UI, right? That's the front end wanted to do. So you can see we somehow in the front end introduce a function. I mean, I'm kind of overloading the function here and there, okay? But it is true. You have functions on the front end, you have functions on the back end. So that's confusing. So this is a function in your JavaScript, right? In your function in the JavaScript, you want to somehow using this to link it so that this Web3 functions can help you to call the actual functions on the smart contract. And then this is how you do, right? After you got the results, and then you can actually either print them out. This is printed out in the console, or this is you can actually show it in the HTML format, which is show it in the UI. Okay, so let's see how we actually do this. This requires you to have some basic knowledge about front-end code. So let's just simply go through that, see whether we can actually read and interpret the logic properly, okay? So let's create a similar function called zombie to owner, and then, which is, we know that this is, right? We already know the mapping structure look like, but now this time we need to do that in the JavaScript, okay? So what we need to do, let's find out the location to code this. Okay. We said that it's called, so define a JavaScript called this, okay? Zombie to owner by giving the ID, right? So you just specify the ID. Okay. So that's how you do that in the JavaScript. Now we need to call it. So you can simply follow the example over here. So you say return. So you want to call the methods, okay? So say my contract dot methods dot what? The variable, right? And you simply call that by id.call. Okay? So let's read this line again to see whether that makes sense or not. we wanted to all the way call the smart contract methods. This is smart contract methods functions. So not function actually. It's a public variable, right? This is a public variable. We wanted to access the data. So the way to do that is just CryptoZombies.methods. You can see here we're still using methods, right? And then we say that here's a syntax by please look up this methods for me, and then by passing the ID, and then you just chain that with the call. Okay. All right, and then they want us to define another functions called get the zombie by owner. Sure, we're gonna do that. So we say function get zombies by owner. And what do you do? Yeah, you need to understand the syntax on your Solidity side, right? Syntax on the Solidity side is an address called owner. So we just need to take the owner as a parameter. Okay. And then we need to return, right? Do the same thing. So you say my contract instance methods dot. You need to call the function, which is this one, by passing the owner. Don't forget the call, right, at the end. All right, that's how in your JavaScript, actually through the Web3 JS and all the way to call your smart contract. Perfect. Okay, now we have successfully called some view and the pure functions or variables on your smart contract. Now we're gonna do a little bit more sophisticated stuff, right? Because we may want to trigger the MetaMask now. Okay. So MetaMask, remember MetaMask? MetaMask is a Web3, has a Web3 front end and a back end, which is the node. They help you to do the account and then account management or key signing in the transaction. So our goal here is in our dApp somehow can interact with MetaMask. Okay. So one way to interact with MetaMask is to understand that MetaMask has an account concept, right? So we need to through the Web3, we can ask this MetaMask Web3 to get an account. So this is how you do it. So you say web3.ether.accounts, which is you can actually get fetch all of the accounts. And if you do 0, it only return the first one, the current one, whatever the UI, you selected, right, as a current. So that's how you get an account. Okay. So what if I remember there's two front end UI. Okay, there's a UI which is your UI, and there's a MetaMask UI, right? So what if I change my MetaMask UI from I just change it to a different account? Whenever you change it, does your dApp actually can fetch it to refresh it, right? To say, hey, oh, your account has been updated, you will change it. So somehow my dApp has to somehow monitor whatever the account you change it. So because there's two client application going on here. Okay, so that's how in your dApp can implement this piece of the logic, which is you can always fetch what is the current account from MetaMask, which is Web3 providers, right? So the way they do that is they introduce some called loop. Just think about it's a smart logic. Sorry, I just like special logic. Special logic is to always checking, right? Check, please check for me. Check if the account has changed or not. If it changed, please update the interface. Okay, so that somehow I can automatically follow whatever the MetaMask has changed the account. And then you do that for every 100 milliseconds. You see, that's why it says that. Please check my variable, which is in my dApp site, that is equal to the current variable, that is I fetch it from the Web3. Okay, so that's how you understand why we need those two logic. And what's the purpose? How do I leverage and use that for my dApp? Okay, now we're going to declare the variable, right? Variable called user account. Always track that. What is my current account in the Web3, which is MetaMask? Okay, at the end of that, we want to copy paste this piece of the code. We just copy paste that because we wanted to okay. Okay, so that means whenever you refresh the page, you know, this has been updated, right? This code will be always checking for that. Awesome. So you have those account interval code as well. You can refer to that variable if you want it. Now we need to go to the update interface line because we need to replace this with exactly what we wanted to refresh, right? So we wanted to refresh this because the account has been changed. Okay. So after you do that, we need to somehow change the function called .then, right? Like, so basically, this is how you do that in the JavaScript. You say, hey, my previous function, whatever the output, please change this to another function. Okay. So we don't have this function yet, but that's okay. But this is how you build the interval loop to kinds of update your user account, and this user account somehow pass on to the getZombieOwner functions, which is the UI will refresh it based on the new account you kind of swap it on the MetaMask, right? Sounds like quite complicated. But the whole point is account switching happen in this UI, not in this UI. So this UI is fetching the account from this one and somehow later on to do rest of the work for this one, okay? Any questions so far? You guys still there? Okay. Awesome, we're gonna move on. All right, so now our job is actually implement this display method, right? So we need to display the zombies on our dApp to show that to the users. So how do we do it? So you just deal with the UI aspect, right? So I will skip this, but let's just see that what exactly we can do that quickly. So look here, this is how they by calling the details and all the way chain and all the way show the UI, right? That's how you typically do that. Okay, let's just go ahead and see how we can implement this stuff over here. So our goal is to displace the UIs by getting the data from the smart contract now, so we need to show it. So the first thing I want to do is to empty out this, right? And you can do that by this. Okay. And then we wanted to loop through all of the IDs using this. Okay. Inside of the loop, they want us to copy the codes that is above for each ID, then use this. Okay. So remember the codes over here. For each of the IDs, we can copy this get zombie details code, right? So let's just go ahead and call that. Make sure your curly brace matches, okay? Okay, so I think we successfully implement this now. So let's see what, at the high level, what this HTML JavaScript trying to do here, okay? So basically, from here, we want to show the current owner all of the zombies to the UI. That's this function trying to do. So because this function will return to me all of the IDs, that means for each one of the IDs, we want to loop through that. So this is a variables, like JavaScript variables we wanted to empty. So you have kind of like say, because if I switch it from Hui's to Mary's, we wanted to empty out and then refresh it from beginning, right? So that's what you do. And you can see here, this is how you kind of build up these variables by putting this HTML, embedded codes into that. What it does here is to actually show this kinds of a little bit lines and tables about the name, DNA, which is all the variables you can call it to get it, right? So that's how you kind of a for each loop by calling this function, and this function will return the zombie information. Again, this zombie information, get it from where? From your smart contract, right? And that data being fetched back for each ID. And then because of that, you're chaining for another function here to actually show it to the UI. So there's a lot of the chains going on here. Okay, so now we got the how to show the zombies to the UI. The most difficult part is actually from your UI, how do you trigger to send a transaction, which is now your dApp is going to ask MetaMask help because you want to auto trigger their UI to pop up and then send the transaction for the right account, right? That's this whole mission here. So instead of calling the call now from the Web3 library, we're going to call send. That is what it says here, okay? So send is going to trigger the actual sign-in transaction, which is we will need the from address. And the from address is, of course, from message.sender, right? From that aspect. And then they also mentioned about send will cause gas, okay? So that's all the things you have to keep in the mind when you actually perform the transaction here. So let's just focus on how the front end will we actually do. So imagine you wanted to call the function, which is Solidity code, right? So that means we wanted to have another JavaScript code, which is kind of do the same, but inside of that, we have to bridge through the Web3, so the Web3 can, on the behalf of us, to call the function. So that's how you call it. Did you see that? Methods dot functions dot, and then you call the stuff. And then once you call it, because send method, you have to pass parameter, right? So you have to pass the the address, and then once you get the return, so we're gonna talk about this on, okay? So that's why they said that send has two kinds of event listeners. It means that it will have some callbacks you can register, and then that's what you can once they return to you, you can write the logic to deal with that, right? So one is called receipt event listener, another one called arrow. So receipt will fire when transaction is included into the blockchain, means the success path. Error means that it's not success, right? So that means somehow it's being blocked. User either could not send the successful guess, and you have to notify the user. So this is very important because once you call that, you have the two kinds of callbacks. So you have to address it, and then you have to deal with that. If it's a receipt situation, how you wanted to do that in the UI, what is the next step you want to do? If it's not succeed, what do you want to show it to the UI? Okay, so that is kind of a syntax or logic look like. Let's see how we can put it into the test. So what we want to do here is, let's go to find the right spot. So start here, right? So they wanna first copy paste the CryptoZombie. Okay, let's just go ahead and copy that, and replace here. Okay, so we have done this copy. All right, and then they want us to implement another function called feed on kitty, right? Remember we have that function before. This feed on kitty almost identical to that one, so we can simply copy paste of the code, right? And take two parameters called zombie ID and kitty ID. Okay, sure. And then it is the same of that one, right? So you will just initially be the same. Okay. And then let's see what we need to change, right? So the first thing they want to change it is of course, because this is the feed on kitty, so we don't want to show the wrong message. Let's change this one. So we need to show the message like this. Okay. So feed on kitty, initially you said that, oh, eating the kitty, this maybe take a while. Okay, so you give an initial statement, a comment, and then we need to call the feed on kitty, right? Because in here you don't want to call the copy this, because we just get the code, from another place. So you want to make sure you call the right one. Okay, you call right one. Make sure you pass the right parameter. Do we? Okay. Once you have it, remember, once you have it, then we need to change some success, right? If it's a success, we don't want it to show the old message. We want to show a different message. We just said that, sorry, ate the kitty, now we sponsor the zombie. All right, just change this message to the new message. Okay, that's about it, I think. Let's see what happened. Yes, we did it. Okay, so we move on to call some other functions, because we have many functions we define in the smart contract. We have not able to call it, right? So we're gonna pick the one called payable function. Remember, we have payable functions, right? So payable function is require gas. That's what it says. So which one we're saying that we need your money. We need to check you have sufficient money, right? The message.value, remember? Level up methods. Yes. So this is how you need to pay. When you send the ether with the functions, we need to specify how much we're gonna do that in for gas. But for gas, you want to use a lower denominator, or for not the ether, but it's really called Wei. So Wei is the smallest subunit of the ether, right? So that's called Wei. So one ether equal to this big number of the Weis. Okay, so you don't need a 1 ether to pay the gas. That would be crazy. So you need to somehow access to get the Wei by giving the ether number and then say return to me as a Wei, right? So that's how it works. So let's see how we can actually trigger this level up, because this level up is actually so this send method, not only you have to provide the message.sender, which is your whatever the count. Now this time you have to provide an additional one called the value, right? So what's the value? The from address, which is the account you own, and then the value, which is you're trying to give the actual parameters. say, hey, please pay this with this gas fee. Okay, let's see how that works for here. Okay, let's add another level up methods. Start here. So we're gonna do a function, level up function. Okay, and then function take one parameter. So pre-transaction, right? Good. So we said that pre-transaction, we want to show the text status message. Sure. So how do we do that? Remember this? Pre-transaction, we do this. But we want to show the right message, right? So after you copy paste, make sure you update that. Yes. Okay. Now we need to call this function, right? And how to call it? We already know how to call it. Contract dot methods dot something, right? Dot actual method. And then when you call dot actual method, you give the parameter. And then you have to say dot send by giving some parameter which is similar like this, right? Look here. Okay, that's how you call the dot send. I don't know, maybe we can move on to the next line. Yes, like this. Yep. So upon succeed, we want to show this. Remember, send always have this dot on, right? So that's what you need to do. So if a succeed, we want to say power up. Okay, because we don't need to chain this function, so we don't need to do this. We just succeed, right? When you call the level up, you succeed. Okay, that's how you level up. We have some issues. Which one is wrong? Do we need to call return? Oh, we want to also show the arrow. Yeah, they didn't mention that, but that's okay. Okay. Yep. Okay, so now we successfully call all kinds of functions now, right? So the last one we want to call is this event, because Solidity has the way to raise the message, but how do we subscribe that event so that my front end can actually be notified, right, for that event? So we do have an events call where a new zombie is created. There will be some notification from smart contract side. So if we as a client side to subscribe it, we're able to get that notification. So that's the events we need to understand, that how in the Web3 as a bridge to make that happen. Okay. So the way to do it is to in your client side code to formally deal with that events, right? So that's what we need to do here. So let's go to see how we do that in here. Another important concept is event. For the event, they have a parameters, right? So you can see event has a parameter. In this particular case, ERC 721 transfer event, they have something that's very unique. They call index syntax, okay? So what does that mean? That means you can when a parameter, event parameter has this index, it means that for this you can actually apply some filter in your client-side programming. Means you can specify, you don't want to subscribe all the events, you want to only subscribe the events based on some filter, right? So that means I can apply a special filter for this parameter concept, but because this filter doesn't have it, that index, so I cannot say, hey, please also show me token ID equal to 5, and I only wanted to be notified for that situation event, right? You can't, because you have not explicitly mentioned about which filters the client side can subscribe it. So that's additional thing you can think about it is you can apply the filter to certain parameters if that allowed in your smart contract side. Okay, so you can see there's some syntax about it. How do you apply the filter? So basically, when you call the events, you can pass on the filter. So this is basically that my filter, please apply this filter when the to address is the current address. That means I only interested in event that is related with my account, right? So that's what it does. And again, on data means that you got the success for data from the event, and then you just chain for the event function. What do you want to do with that? So you can see this is how you actually get the data, and you can actually do rest of the stuff. Okay, same thing here. Do you see that as syntax? Data, you get the value, and then you do whatever you want. Awesome. So now we know how to apply the events, right? There's a third thing we can do. This is called query the past event. So not only you can be notified the current event. What about I'm interested in the past events, right? So how do you do that? You can actually apply the filter. The filter, which is specify the from and to blocks to give the Solidity a time range. Remember, events is event logs, which is also being stored in the Solidity side. In the Ethereum side. Okay, and then the way to fetch the history is through the kinds of a block time, right? Like 0 to this. So that's how you deal with the blocks, kind of to get the portion of the back histories. And then once you get the data, you can do whatever you want about that. So it's not quite sophisticated, query, you have it. So that means Solidity only provide a very basic event queries allow you to do. And then most of the logic probably at your client side, to deal with that. This is also interesting paragraph. So they mentioned about it is, yes, Solidity has a special way to store the event logs. And then event logs from Solidity perspective is cheaper because based on their implementation is cheaper storage compared to another storage called storage, right? The keyword called storage. So people have leverage on that. People basically can emit quite a lot of the events into the event logs because it's cheaper. And then you can use the client side to kind of get into more insights about what's going on about my smart contract, which is you don't have to directly fetch the actual data that is in your data variable, right? But you can actually get the more, you write the more information in the event logs, and then you can fetch it later on. That's what it's trying to say. That is, could be a strategy there. Again, it depends on how the Ethereum set the rules, right? That they're the blockchain layer 1 protocol designer. Okay. Another important thing here is they said that events are not readable from the contract. So that's also very important to know that. Okay, so let's quickly finish this, okay? So what we want to do here is to, at the end of this one, copy paste above because we want to listen to this event. This is what we do. Okay. And then from the line of the updating the UI, we want to call this, right? Sure. Okay, let's read this again. This is how you subscribed a transfer event. And then in the event, we apply a filter because we're only interested in, because event is for that smart contract. It's kind of like all the event logs, regardless, you know, the my account, every account, right? So I'm only interested in my current account. So that's why the filter is applied. And then when you get the data, this is how you get the data. And then I want to pass that data to the next, right? So you just call this one. So once I got a notify, I want to move on. I want to say, hey, please get the zombie by this owner, if the transfer has happened, right? All right. So that's basically all we have learned in the dApp side by utilizing Web3 and to kind of go through some different types of functions you can call. Let me go back to here to just quickly summarize what's going on, okay? But you can read that later on. But congratulations, everyone. We have successfully gone through all of the crypto 6 lessons today. And then this is a big achievement for us. And I hope you're enjoying this 3 sessions here. And then we will continue on some more other aspects of the technical side, so deep dive the Solidity and other blockchains stuff, okay? But before we leave today, I just want to finalize this very important things I have talked about here, but just what exactly inside of the dApp you have to keep in mind, okay? dApp is the front end, mainly front end logic. So you have to deal with HTML, CSS for how do you present the data in your UI, how do you connect the data, how do you actually get the data object from your smart contract, right? So that's how you do. And then JavaScript is a key here to kind of inside of your dApp. So you make sure you have an import couple right JavaScripts, how you import with the Web3, how you import the ABI, that's the JavaScript. And then very important thing is how do you get the contract object in your dApp? How do you actually call some public variables in your dApp, which is using the call method? How do you get the view and then pure functions, right? Those are a read-only situation variables you can do. And then we talk about how do you trigger the functions. And then in the function side, you have to deal with the successful receipt, deal with the error, and then make sure whatever the data you actually come back, how do you actually reflect that on your UI? So the tricky part here is really your dApp and the MetaMask relationship. You have to kind of understand it. So that's why Web3 in this particular case is the MetaMask. So how do you get the account? How do you actually trigger payable function, which is you have to specify the way, which is gas, right? Now the last part is really the events. Okay, so how do you deal with filter event, query the past events? What does that mean? Indexed parameters, which is specified in the event side. So all things have to be, all little things have to be kind of crystal clear, so that you don't hit the roadblocks because you haven't understand each little ones. So that's all the details happens in the dApp site. And then I hope you enjoyed today's sessions, but we actually achieved quite a lot today. And then that's about it. All right, thank you guys. And then thank you everyone. Thank you all here. And then we finally come here. Yeah, we will do next sessions about like actually using different, not using this course, basically we have to set up the local environment to do that. But overall, we're on the right track. So hopefully you're enjoying it. And then you have a great weekend. Everybody have a great weekend and see you next time. Okay? Bye-bye.